So now that we have an idea of what POMDPs are about, maybe we should talk a little bit about what it might mean to do reinforcement learning in them. Because we've basically talked about planning. If we have a model of the POMDP, we can run some calculations. We can run value iteration to get a way of deciding what to do. Actually, did I say that? I think I did not say that. I think what I said is how you get a value function. Is it clear how you would use a value function to get a policy?
In the same way you would for an MDP, right? Yes? No? That's not true?
Yeah, that's right. If you have the model, then you can use one-step look ahead with the value function to figure out what the optimal action is in any given belief state. Once we've run value iteration and gotten an approximation of the optimal value function. Oh, and what about that? Value iteration doesn't actually necessarily converge.
It doesn't? You didn't tell me that.
I did, actually, when we were doing in lesson AAA.
Lesson AAA?
Yeah, the advanced algorithm analysis. What we said there is that value iteration converges in the limit to the right value function, but after any finite number of steps, it need not have the optimal value function. But it will, after some finite number of steps, have the optimal policy. That's not going to be true in the POMDP case because there's an infinite number of states.
Oh, I see.
But it is going to be the case that we get an arbitrarily good approximation after some finite number of iterations.
Wait, arbitrarily good approximation of what?
Of the optimal value function.
Wait, but not necessarily the optimal policy?
Yeah, if you do one-step backups or one-step look ahead with a near optimal value function, you'll get a near optimal policy.
Okay, so that's nearly good.
Now that we've talked about planning in POMDPs, we should talk about reinforcement learning in POMDPs. Charles, what's the difference between planning and reinforcement learning?
Well, in planning, you know everything, and in reinforcement learning, you don't know everything, and you have to explore and exploit and do all that other stuff in order to find things out. Like you don't know the model necessarily, and that makes the problem harder. So what you're telling me is reinforcement learning is harder than planning in the way you're using the words, and POMDPs are more difficult to deal with than MDPs. So reinforcement learning in POMDPs should be like, is that additive, multiplicative?
So reinforcement learning in POMDPs is hard, like super hard. Actually, planning in POMDPs is formally undecidable in the sense that...
Undecidable?
Yeah. If I give you a POMDP and ask, is this the optimal first action to take from this belief state? If you could solve that problem, you could solve the halting problem.
Holy cow. Wait a minute. That has profound implications.
No, it doesn't.
Yes, it does, because we're human beings running around in the world. We're living in a POMDP because we can't know everything. So you're telling me that even if I could relive life an infinite number of times, I still don't know what the right thing to do is. You're saying that life is unknowable. It's undecidable. You can never know what to do. That's profound. Wow. I need a moment.